our metric prefixes. We're going to use the factor label method, which is also referred to as dimensional analysis. You need to know your SI units and their abbreviations. You need to know those prefixes, their abbreviations, what they mean in terms of powers of 10. If you haven't memorized them, you need to go ahead and do so before you do these problems. G is the SI unit for mass, grams. We're concerned about the prefixes. So M stands for milli, which means 10 to the minus 3. N stands for nano, which is equal to 10 to the minus 9. So let's first estimate what our answer might be. Which one's larger, milli or nano? Milli is. And so that means there are lots of nanograms to make a milligram. So that means our answer is going to be a number that's greater than 1. I hope you can rationalize this with me. If not, pause the video and think about it. Let's take our quantity to be manipulated, and we want to set up a conversion factor to where we cancel out milligrams. Well, I don't know a conversion factor between nanograms and milligrams, so we're going to actually do this stepwise. 2 steps. We're going to go first from milligrams to grams, then we'll go from grams to nanograms. So milli means 10 to the minus 3. So the identity, the conversion factor that we want to multiply by is 10 to the minus 3 grams is the same as 1 milligram. 10 to the minus 3 grams divided by 1 milligram. That way milligrams cancels. You don't put 10 to the minus 3 with a milligram. Otherwise, you'll be off by a factor of 10 to the 6. Now we want to cancel out grams and wind up with nanograms. So nano means 10 to the minus 9. So 1 nanogram is the same as 10 to the minus 9 grams. Grams cancels. We're left with units of nanograms. It's going to be 8.63 times 10 to the 8th. Our answer is greater than 1, as we predicted. We've got the right units. And we'll talk about significant figures in a later section of this course. But I've got 3 digits, and we'll wind up with 3 digits. The next problem involves liters. The SI is not a fundamental unit, but it's a unit for volume. We want to convert from liters to milliliters. We'll use the prefix milli again, which means 10 to the minus 3. So which one's larger, liters or milliliters? Liters is larger. So we're going to need lots of milliliters to equal a liter. So odds are our answer is going to be greater than 1. Let's take the quantity to be manipulated, 0.687 liters. We'll come up with our conversion factor. Let liters cancel. We'll put milliliters in the numerator. Milli means 10 to the minus 3. So that doesn't go with milliliters, it goes with liters. Liters cancels. That will leave us with milliliters, which is the unit that we're after. And our answer will be 68.7 milliliters. Or you could write it as 6.87 times 10 to the first milliliters. Whether you write the answer in fixed notation, like 68.7, or scientific notation, like 6.87 times 10 to the first, doesn't matter, unless the problem at the outset tells you to write in scientific notation or in fixed notation. Next problem involves meters, the SI unit for length. And we're going to do a conversion factor between centimeters and kilometers using the factor label method. Centa means 10 to the minus 3, 10 to the minus 2, excuse me. Kilo means 10 to the plus 3. If you know conversion factor directly between centimeters and kilometers, you could use it, but I don't. And so we're going to once again do this as a multi-step problem. Well, let's think about what our answer is going to be starting out with. Centimeter, less than an inch. Kilometer, more on the size of a mile. So just a few centimeters is going to be give us an answer that's very much less than 1. It's much smaller than a mile. So let's say our quantity to be manipulated, 89 centimeters. We're going to go from centimeters to meters, and then to kilometers or kilometers. So centimeters will be in the denominator. Meters, my intermediate unit, will be in the numerator. And centi means 10 to the minus 2. So 1 centimeter is 10 to the minus 2 meters. Centimeters will cancel. Now we go from meters to kilometers. There are 1,000 meters in 1 kilometer. So now meters cancels. We'll wind up with units of kilometers. It'll be 8.9 times 10 to the minus 4. 8.9 times 10 to the minus 4. Lastly, we have another problem involving length meters. This time the prefixes are capital M, which is mega, capital G, which is giga. Mega means you've got 1,000,000 of whatever you're observing. Giga means you've got 1,000,000,000, or 10 to the 9. Once again, I don't know a direct conversion factor. I'm going to go from megameters to meters, then to gigameters. So 72 megameters. I want to cancel megameters. I have my intermediate unit of meters. Mega means 10 to the 6. Now I want to cancel meters and wind up with gigameters. Giga means 10 to the 9. Megameters divided by megameters cancels. Meters divided by megameters cancels. And that gives me gigameters. And I come up with an answer of 0.072 gigameters. I didn't estimate it beforehand, but I can go back and see if the answer makes sense. Which is larger, megameter or a gigameter? The gigameter is. So we take a lot of megameters to make a gigameter, which means it'll take fewer gigameters to make a megameter. So our answer should be less than 1, and in fact, it was less than 1. Now, somewhere along the way, many students have learned some little mnemonic device that looks something like this: micro, milli, centi, deci, kilo, mega, giga, tera, and they'll do some sort of moving of the decimal point and fix their exponents that way. More times than not, when students do rely on that method, they wind up making a mistake. So I urge you not to do something like that, but to in fact use dimensional analysis factor label method. I think it's a clearer method and will lead to less mistakes along the way.